All right, once again, welcome to Get Smart with Stanford. And again, we are dealing with a grade 11 question paper. This is question 2 of the paper 1. So let's get down to it immediately. We've got this question here. You are required to simplify fully and without using a calculator. All right, I will recopy or I will rewrite the question here at the bottom, and then on the right hand side we are going to work out. So question 2.1, they say we are simplifying fully without the use of a calculator. 3 to the power m plus 4 minus 6 times, remember that this dot means multiplication, and 6 times 3 to the power m plus 1, all that is divided by 7 times 3 to the exponent m plus 2. Now let us run to the other side and see how we are going to work on this. So when we have that, the first thing that I think we need to do is to break it down and separate these exponents, because you can see we have the variable m and we've got the number 4, and on the other term we've got the number 1, and on the denominator we've got the number 2, all of that on top of the same base, which is 3. So we are going to break it down like this. You will remember that when you have an exponent, or when you have got something like a to the power c plus d, this is the same as a to the power c times a to the power d. So we're going to apply this rule of exponent, which is a product rule. It's a product rule of an exponent. So that's what we are going to apply. Let us apply it to this one and see what it gives us. So we are going to have 3 to the power m multiplied by 3 to the power 4. We know that when we've got the same basis, then we add the exponent, and the exponents were added here. That's because it's coming from this. That's where it's coming from. So we have that, and in the next term we've got 6 as it is times 3 to the exponent m times 3 raised to the exponent 1. And you will all remember that when we've got an exponent 1, we don't always show it. When you have got x, you just need to know that it's to the exponent 1. Every number or everything that is written is raised to the exponent 1, but we don't even show it. So, and on the denominator we've got 7. It's multiplied by 3 to the power m, which will be multiplied by 3 to the power 2, applying the very same rule of exponent, which is the product rule. So you must never forget to write the equal sign like I did, because sometimes you will be penalized for that. And then what is the next step? The way I see it here, there is, on this first term here, we've got something similar to the second term. we've got 3 to the power m. Then, given that we are going to take out the common factor 3 to the power m, and then we open the bracket, we'll be left with 3 to the power 4 from the first term minus 6 times 3, which is 3 to the power 1. If you multiply this common factor back, it should give you what you are left, what you had in the previous step. So at the bottom here, we're just going to rearrange this, but it's still the same. We'll have 3 to the power m times 7 times 3 to the exponent 2. So at the bottom here, I didn't change anything. I just rearrange because 2 times 3 will give you the same answer as 3 times 2. Hence, I say I did not change anything. I did not even change the essence of the originality of this. So, the next step, what are we going to have? You can see we are multiplying on top here, then 3 to the power m, and also at the bottom we are multiplying, then 3 to the power m will cancel each other. What are we left with? 3 to the exponent 4. What is 3 to the exponent 4? It's let's calculate. It's 81. 81 minus 6 times 3 is 18. And at the bottom, we've got 7 times 3 squared. 3 squared equals 9. So we've got 7 times 9. 81 minus 18 will give us 63, as well as 7 times 9 will give us 63, and our answer is 1. So these are some of the questions that you should never lose even a single mark from them, because simplifying is quite easy, no matter how complex the question may look. But once you try it and apply the correct mathematical methods, trust me, you are going to get everything, and you are not supposed to lose any mark on this. So that's the final answer on question 2.1. Now let's move to the next one. Let's move to the next one. What does the next one is? Here we are solving for x on these two questions, 2.2.1 and 2.2.2. We will be solving for x in here and here. So the first question, I can see that it's not very visible, so let me rewrite it. We have x to the exponent of negative 3 over 4. X to the power 3 over 4 equals 8. Let's go back to the other side. We are working this side on the right hand side. Let us copy the left hand side as it is. And the right hand side in exponential form is 2 to the exponent 3. And what next can we do? We need to reciprocate this exponent, and what we're going to do this side, we're also going to do on the other side. So reciprocating this exponent means we are going to write x to the power minus 3 over 4 multiplied by 4 over negative 4 over 3. Now we are writing this upside down. We are reciprocating. It means writing it upside down. So what we did on the right hand side, we also need to apply on the left hand side. Here we are going to have 3 times negative 4 over 3 as well. So this side, these boys are going to cancel, and the girls are also going to cancel together with the negative sign. and on the right hand side also the 3 will cancel 3. What are we left with? On the left hand side we're left with x equals 2 to the power negative 4. 2 to the power negative 4 can be rewritten in a fractional form, which will be 1 over 2 to the power positive 4. And our x equals 1 over 16, because 2 to the power 4 equals 16. So this is our final answer. You see how simple this is. You don't even need to struggle. You don't even need to think very hard about it. It's a very simple thing. You just need to know which methods to apply. And whatever method you're applying, you need to ensure that it's mathematically correct. And now let's go to 2.2.2. It doesn't look very friendly, but trust me, it is very easy. We've got 4 to the power x minus 2 to the power x equals 2. Let's go to the other side and work. 4 can be rewritten as 2 squared. So it will be 2 squared, and the exponent 2 is going to get the x there. They are going to multiply each other. Then we have 2 to the power 2x. Everything else can be rewritten as it is. So the first term here, this one, we can rewrite it in this way. We can say, just to make it look the same as this one, we can rewrite it as 2 to the power x squared. We didn't change anything here because we know that 2 times x is 2x. Therefore, our exponent is still more or less, actually it's still the same. We didn't change the essence of the original one that we got. It's still the same. And here we're going to have 2 to the power x equals 2. But now, because we have this negative sign here, we cannot say that because we've got the same base, then we are now going to say we write the same base and add the exponent and deal with the exponents or something like that. It's not going to be as easy as such, you see. And we cannot really take the common factor, because when you take the common factor here, of course you'll be left with 1, but here you'll take 2x to the power 2, and this exponent will be left with nothing, and it's going to give us something so funny, you know. So now let's continue. But here, when I look at this, it's not so easy to simplify this. Let us now go and apply the let method. Here is the let method. We can use any variable. I'm choosing to use y. Let's say y equals 2 to the power x. That basically means that wherever you find 2 to the power x, you are going to substitute it by y. Let us use this equation. Then we have 2 to the power x, we write y, and it's got an exponent 2, so we'll have y squared minus y equals 2. Now let us transpose the 2 to the other side. We'll have y squared minus y minus 2 equals 0. With this trinomial equation, we can factorize. Let us try and factorize. Minus 2 and positive 1 seem to be the suitable values. Therefore, our y equals 2, or it is equals to minus 1. But let us look at what we are dealing with. We are dealing with 2 to the power x, and this exponential is positive at all times. Whichever value you can substitute, even if you can substitute this x by negative 1 billion, it's still going to be positive, even though it will be approaching 0, but it will never be 0 and it will never be negative. You'll always get a positive answer. That basically means we are writing off the value of y as -1, because these 2 to the power x will never be a negative. So we are writing off that one, and we are going with um, we are going with positive 2. I hope we understand each other there. So since we are going with positive 2, or maybe to try and make you even understand more, we can just look here on the left hand side and say this one, an exponential an exponential expression, um, exponential expression like 2 to the power x, and write this facts here. It is always positive. Just to repeat what I've just told you, is always positive, and it can never be 0. It can never be 0, and it can never be negative. And that is because the expression 2 to the power x is always greater than 0 for all real values of x. So these are the taking points. Therefore, we cannot consider y is equal to -1. Then now, I think we can continue with our calculations. As we have agreed that we are going to continue with y equals 2 only. But what is this y? We said here that y is equal to 2 to the power x. That means we need to go back to the original and take 2 to the power x as our y and equate it to 2. Now that we've got the same basis here, then we can drop the basis and deal with the exponents, and we know that the 2 as it is always to the power 1. Therefore, the value of x is equal to 1. That is our final answer. I hope you understand, and if you need more explanations, feel free to call me. Just text me on WhatsApp on the number that I will give at the end of this video. And also, you can feel free to send me an email, getsmartwithstanford@gmail.com. So let us continue. They keep on looking scarier and scarier. This one, 2.3, when I look at it, Yeah, it can scare you, but there's nothing at all here. You just need to relax and think of the mathematical methods that you can apply. So let me rewrite it. We've got is 2.3. They say if x is equal to 3 minus square root of a over square root of 2, and then and y being equated to 4 plus square root of 9 over square root of 2. Now we need to find the value of x plus y all squared. Ah, okay. On this one, I think if we can equate x and y and find the value of a, it's possible. Yes, we can find the value of a. Or we can right away, we know that x is equal to this, we substitute it in here, and we know that y is equal to this, we substitute it in here. Let us start with this one, and then if we still have time, maybe we can also apply the method that I was talking about and see if it's going to give us the same answer, because you can use various methods in mathematics and still get to the same answer. So here we go. Let's look into it now and see how easy this is. We say we are substituting into x plus y all squared. So what is x? X is 3 minus square root of a all over square root of 2. And we have this plus, we put it here. And what is the value of y? The value of y is 4 plus square root of a all over square root of 2. So nice. Must not forget that we have got this exponent, which is to the power 2. So when we are adding like this, let us start by dealing with what is inside the brackets before we can deal with what is outside, because what is inside seems to be more complex. Then now let us go on to say what is the lowest common denominator. Since they are all the same, then we just use square root of 2. 2 divided by 2, square root of 2 divided by square root of 2 is 1. 1 times 3 is 3. 1 times minus square root of a is minus square root of a. Plus square root of 2 divided by square root of 2 is 1. 1 times 4 is 4. 1 times square root of a is positive square root of a. So if we have this, you can see that we have minus a plus a. Minus square root of a plus square root of a. And if you want to write it in standard form, you can say square root of a minus square root of a, and they cancel each other. They subtract each other, and we are left with 0 there. So this is what we have. On top here, we'll be left with 3 plus 4. Oh, yeah, I forgot to square. You see the mistakes that we are making, that can cost us a lot of marks. We must never forget to continue with the square. So on top, 3 plus 7. 3 plus 7 on the numerator is, oh, what am I saying? I'm sorry. 3 plus 4 equals 7 divided by square root of 2. We are squaring all of them, and 7 square equals 7 times 7 is 49, and square root of 2 squared, when we are squaring a square root, the answer is whatever that is inside the square root or under the square root. and in this case is 2. And if you want to go further with this one, you can say 49 divided by 2, you are going to get 24 and half, or 24.5. So that's our final answer. But now I promised you that we can apply a different method, but I wouldn't really advise you to apply that one, because I'm starting to think of it, to think that it's a very long one. But even though it's very long, let me show you, because you never know, you might find it easier than this one. So we've got x, let us equate it to y. If we are equating it to y, then the value of x is 3 minus square root of a over square root of 2. The value of y is 4 plus square root of a over square root of 2. So what we can do here is cross multiply. Apply the cross multiplication. When we apply the cross multiplication, we are going to have, I'd prefer to start with the one that I've drawn a red arrow. We'll have square root of 2. You can start with the other one, square root of 2 times 4 plus square root of a. It doesn't matter, you're still going to get the same answer. We'll have 3 minus square root of a equals square root of 2 into 4 plus square root of a. When it's like this, let us divide both sides by square root of 2, because we know that what we do on the left needs to be done also on the right. Then the square root of 2 will cancel this one, because square root of 2 divided by square root of 2 equals 1. So on the left hand side, we are left with 3 minus square root of a, and on the right hand side we are left with 4 plus square root of a. If things are like this, then we might need to transpose. Let us take this 3 to the other side and take this square root of a to this side. Then we'll have minus square root of a minus square root of a equals 4 minus 3. 2 minus 2 square root of a equals 4 minus 3, it's 1. Then let us divide both sides by minus 2. We divide both sides by minus 2. Let me show it to you. I don't want to skip anything yet. We divide both sides by minus 2, and this one cancels this one. And then on the left hand side, we are left with square root of a, and on the right hand side, we are left with minus half. But now we want to find the value of a. What do we do to remove the square root? We square. But we cannot just square one side. We are squaring both sides. So here we'll be left with a is equal to now a positive half, because when we are squaring a negative, we get a positive. So now that we've got the value of a, then we can simply, let me erase everything here, because you've already seen. Rather, you can always go back to watch that one. You just need to bear in mind that the value of a is half. The value of a is positive half. Then let us come here and say x plus y squared, and then substitute with the value of x is 3 minus square root of, now instead of putting a, we say 1 over 2 over square root of 2. This bracket must cover everything, plus, remember, we need to get the same value that we got on the other step. If we don't get the same value, then it means something will have been wrong. Then the value of y is 4 plus square root of, we know the value of a, now it's half, divided by square root of 2. They are all squared. You will remember that we used the square root of 2 as the lowest common denominator, and here we'll have 3 minus half, the square root of half, plus 4 plus the square root of half. Still remember to square all of them, and here minus half chows minus half. I'm sure from here you can see that we have the same thing on the numerator. We're left with 3 plus 4, which is 7. On the denominator we have the square root of 2. They are all squared, and we still have 49 over 2, which equals 24 and half, or 24 comma 5. There's no difference there. It's the same thing. So now we erase because we got to the same answer. You will decide which method is easier for you, and there can still be another method. I'm not going to work this one out. You will work it out at your own time, but I just want to get to the first, second step and show you what you can do. Since we have x plus y all squared, and when you multiply this out on the two brackets, because we know that this is x plus y into x plus y, then you are going to have x squared plus 2xy plus y squared. So you are going to substitute this wherever you find x, and you are going to substitute this wherever you find y, and I suppose you will get the same answer that we got, which is 24 and a half. Let us look into the last one, 2.4. They say show without using a calculator that the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40 equals 120. Whoa, lo, lo. Okay, let us rewrite that. It's the 12th. Remember, the 12th root of 10 is different from 12 square root of 10. 12 square root of 10 would be like this. This is 12 square root of 10, but what we are dealing with here is 12th root of 10. 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40. Remember, the square root originally always has a 2 here. We would say is the second root of 40 and not the 2th root of 40. Huh? We don't have tooth. We don't have such. And if we had 3, you can call it the third root or the cube root. We know in mathematics we normally call it the cube root when we have 3. But when we have 2, we don't even write the 2. We just need to know that is the square root. So the square root of 40 equals 120. So I choose to deal with the left hand side. You always need to show which side you are dealing with. You always need to show that. If you would be dealing with 120, trying to make it look like this, then you would say you are dealing with the right hand side. But we can see 120 is just a single value there. That will not be so easy to calculate it back and bring it to what we have on the left hand side. So we are dealing with the left hand side. So what is our left hand side? It's the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40. This is the left hand side. Yes, it's so nice, eh? When I look at it here, we've got 1 times 10, which is equal to 10. And here we've got 64 times 10, which is equal to 640. And here we've got 81 times 10, which is equal to 810. And here we've got 4 times 10, which equals 40. So if we can separate them like this, I think we can go somewhere. But this one, even if we can leave it like this, it's just like that. But because here we've got a 10, we've got a 10, and we've got a 10, then let us do something with those. And now going to our working space here on the top right, we will continue with the left hand side. The 12th root, let us leave it as it is. 12th root of 10. And do not say 12th square root of 10. It's not like that. It's the 12th root. And the 6th root of 64 times 10 times the 4th root of 81 times 10 times square root of 4 times 10. Remember, we are doing this without the use of a calculator. So do not cheat and use a calculator. Let us try and work on this one till the end. Then now let us check the 6th root of 64. If we are to write 64 in exponential form, then it would be 2 to the power 6 times 10. And we've got the 4th root of 81 can be written as 3 to the power 4, and we still have times 10. And 4 can be written as 2 to the power 2 times 10. Wow, how beautiful is this? Very. We continue with this and we say, now you will remember that when we have something like square root of a is the same as, you will remember that I told you there's always 2 here, is the same as a to the power 1 over 2. if we have a cube root of a is the same as a to the power 1 over 3. If we have 15th root of a is the same as a to the power 1 over 15. So we are going to apply this method onto all these terms that we have here. Then the first one will have 10 to the power 1 over 12 times, here we'll have 2 to the power 6, that's the 6 that's already there, multiplied by 1 over 6 times 10 to the power 1 over 6. And with regard to this, let me show you where this is coming from. You will remember that when you have square root of a times b, this is the same as square root of a times square root of b, which is a to the exponent half times b to the exponent half. If you will know that, then you will see that we have applied the same method. And let's remove this box. We are multiplying by 3 to the power 4 times 1 over 4 times 10 to the power 1 over 4. We are multiplying by 2 square times half times 10 to the power half. This is equal to, let us leave the first one as it is, 10 to the power 1 over 12, and here 6 and 6 will cancel each other and we'll be left with, now we are multiplying by just 2 to the power 1, which is just 2. I'm not going to write that. You are in grade 11, you are supposed to know that by now. 2 to the power 1 times 10 to the power 1 over 6. Let me write this one nicely. 1 over 6. And again, the 4 and the 4 will cancel. We are left with 3 times 10 to the power 1 over 4. Again, the 2 and the 2 will cancel. There we are left with 2 times 10 to the power 1 over 2. So if it's like this, let us group them. We are going to take, let us first write these ones that haven't got the exponents. Then that will be 2 times 3 times 2 times these other ones, because we've got the same base multiplied by the same base multiplied by the same base multiplied by the same base. We just write one base and add the exponents because they are multiplied. Then it will be to the power 1 over 12 plus 1 over 6 plus 1 over 4 plus 1 over 2. When you add these together, they are going to give you 1. They are going to give you 1, meaning we just have 2 times 3 times 2 times 10. Show you already have the answer. Sorry about that. Times 10. this is 12 times 10. 12 times 10 equals to 120, and you need to always remember that it's equal to the right hand side. Now we have equated the left hand side to the right hand side. That's it for this lesson. I hope you have learned, I hope you have enjoyed yourself with this lesson. So till we meet in the next video, what I'm going to do now is give you the number that you can contact Get Smart with Stanford on using WhatsApp, and also the email that you can contact me on. So whichever question you've got, be it in grade 8, 9, 10, 11, 12, feel free to contact Get Smart with Stanford with your question, and you will be assisted. So next I'm going to give you my details. The phone number that you can call me on. Let me just enlarge this so that I can make my number clear and visible. Clear and visible. If you need it to be clear and visible. The number is 064 663 0943. 064 663 0943. And the email that you can get us on is getsmart getsmartwithstanford@gmail.com. Feel free to contact me and ask for any explanation, and I will be with you. Thank you. Have a good one. Don't forget to subscribe to our YouTube channel and share with your friends. Follow us on TikTok and on Facebook. Everywhere we are just Get Smart with Stanford. Thank you.